So now we're going to have a talk that is sort of a preview of the kind of lightning talks we're going to have tomorrow, updates on things that have been talked about at past developer summits. Sara and Chris are going to talk to us and give us an update on ZFS channel programs.
Great. Hi, my name's Sara. I was an intern at Delphix this past summer working on channel programs.
And I'm Chris. I've been working at Delphix on channel programs for on and off for about the past year.
Yeah, so we're just going to give you an update as to where the project is. It is happening. Yes. All right. Also, yell at me if you can't hear me. So first I'm going to give some motivation for those of you who are unfamiliar or don't remember as to what channel programs are and why we want them. So the basic premise is that there are many ZFS administrative tasks that people who run ZFS have to do frequently. A prime example of this is deleting a snapshot. So the way deleting a snapshot works is you have this ioctl, and from user land you call it, and we go into a syncing context, and it's all deleted, and everything's consistent, and it's great. So we have many ioctls of this kind for creating things, making snapshots, getting properties, setting properties, all that kind of stuff. So where things start to get more complicated is when you want to do slight variations on these operations. For example, if you want to delete all the snapshots of a file set. So today how that works is you'd write a script that would call something to give all the snapshots. You'd have a list of them, and then for each of those snapshots, you would call your delete ioctl. So this is slow, and it has consistency issues. So it's slow because you have to go from open to close context for each deletion, and it has consistency problems because when you're going from open to syncing context, you have the possibility that things will change. Your list of all the snapshots may be inconsistent. You may try to, maybe some other process deleted that snapshot. Maybe now there are more snapshots than when you started doing this. So basically, you don't have guarantees that the state of the world when you started trying to do this deletion operation is going to remain the same. So basically the question is, how do we solve this problem? One possible solution, which is kind of the path that a lot of these things were going down, was, okay, well, we'll just make a new ioctl. The ioctl will be delete all the snapshots, and it will just go in syncing context, and it'll do it all, and it'll be consistent, and it'll be great. But that kind of raises the issue of, okay, it's not entirely clear what the semantics of that system call would look like. How would it react, for example, if it failed to delete a snapshot? Should it keep going? Should it stop? Things like that. So it's unclear exactly if you make a new ioctl like this, what should it do? So the solution that was developed for this purpose is channel programs. So basically, a channel program is all that complex logic of what do we want to do surrounding this system call, this ioctl, and pull it into a Lua script. And then once you have that, you can execute it entirely in the kernel. So basically, the control flow is you're in user land, you have this channel program ioctl, which accepts a script that you wrote. It'll go to syncing context, and well, first it'll interpret it, and then it'll go to syncing context. And in your channel program, you can have a program that says basically, get all the snapshots and delete each of them. And it'll do that all within one sync, and it will be quicker because it doesn't have to go in and out of syncing context, and it will be atomic because, again, it doesn't have to go in and out of syncing context, and it'll be great. So yeah, basically, people have been working on this for a while, and we have quite a few features implemented. So we have these iterators developed. Like I was saying, you can list the snapshots, you can list the children of a file system, I think you can list the clones, things like that. We have deletion supported, getting properties from a data set, listing all the properties applicable for a file set, and then recently the ability to promote clones into data sets. Yeah, so I'll just give a quick example of basically what it took to implement one of these features, which was what I was working on last summer. So this is the example of getting dataset properties. So file systems, volumes, snapshots, they all have some subset of about 60 different properties that have to do with creation time and available space and how many clones they have and what kind of like compression features are turned on, basically anything you can think of. And so this ended up being, okay, where are all these properties? They all exist somewhere in the kernel. We know we can get them. And can we find them? And should they be available from syncing context? So there's a fair amount of inconsistencies to where these are stored. Some of them are computed kind of on the fly. One example is a particular property that this is basically like the user used property, which requires being given a username and then it resolves it by contacting an LDAP server. And we thought we probably shouldn't try and talk to an LDAP server while syncing. So we didn't do that and just required that a numeric ID be submitted. And there's more work to be done for this. Basically questions like, because we're reading these properties, there are some ZFS properties that are read-only. Perhaps there are some that we could access without forcing a sync, which would make them even faster. So yeah, it was really interesting to kind of see the taxonomy of ZFS properties. They're like distributed everywhere. And now we have basically the ability to get a consistent view of the ZFS metadata state combined with this other list system properties. You can basically iterate over the system properties, call get prop on each of those properties, and then have a view of like, okay, this is what the world looks like. I know it's what it looks like because it was done over one sync. The state is consistent. It's great. So now Chris will talk a little bit about current status and future work.
Cool. So currently, we have channel programs integrated into our internal fork of Illumos at Delphix. We've been using it in production for a couple months now, and it's sort of been reaching a stable state. We're currently working on adding additional library calls, expanding the interfaces available to channel program scripts. Currently, kind of up on the roster for that is making snapshots, creating file systems, rolling back file systems. Basically trying to kind of expand to a point where we have most of the core libzfs functionality available to a channel program. The interface for this has reached a fairly consistent state. We can pretty well depend on like what the output from a channel program is going to look like and how to control it without worrying like, okay, is this like library call or feature or something going to change at some point in the future? Yeah, the
Illinois.
autocorrect has introduced a typo, but the pull request for introducing this to Illumos is going to be out pretty soon. We should be upstreaming that like fairly imminently. As a general overview, this code is sizable, but fairly well compartmentalized from the rest of ZFS in that we've added this Lua interpreter and a fair bit of infrastructure to deal with it. But modifications to existing ZFS code is fairly minimal. We have like some refactoring of some dataset layer code that had to be done. But for the most part, the only significant changes are one or two places where we've experimented with using channel programs to actually re-implement existing ioctls. So for example, the destroy snaps ioctl now uses a channel program to vastly simplify a lot of the sort of iteration and error handling that it needs to do. And yeah, so I'll be available during the hackathon if anybody is interested in looking at this code. And yeah, this is sort of open to additions. Yeah, any questions?
Yeah, so there are definitely certain safeguards put on, like you can provide like a time limit of how long this is allowed to execute before you just say it's bad, we're going to stop now. And then also for each of these things that we're implementing, we try and put in like a certain amount of thought of like, is this something you should be allowed to do? And also, can you verify the behavior of what you're going to do? So for most of these like sync tasks, there's a corresponding check. So for example, if I want to delete this file system, I can run the check version of that function and say, is it going to actually allow me to delete it? Yeah, things like that.
Yeah, in addition, there are like explicit time, there are explicit time and memory limits, and you can only run one of these channel programs as root. That should not be possible.
Digging a little deeper into what you said, you covered the bigger picture. I want to concentrate on something specific. A lot of deployments delegate ZFS data sets and recursive children to zones. The concern I have is that root in zone can screw global or root in other zone. Have you tested that? Have you considered those attack vectors, those attack surfaces?
We haven't looked in depth at the interaction between this and zones.
yeah.
Oh, sorry. The question was like, how does this feature and say like running a channel program as root interact with, say, having zones and potentially being able to, like, through some attack, modify data you shouldn't be able to. Is that-
I don't want a channel program breaking out of zone.
Right.
yeah. We haven't looked in depth at the interactions between channel programs and zones yet.
But thanks for bringing that up. That's really interesting.
You can't run the channel program from Windows 10 today. So you have to be rooted.
Yeah, exactly.
Oh, say that
Yeah,
aloud.
you can't run a channel program within a zone. You have to be root in the global zone. Yeah.
That's the goal, to be able to like run it as root or even as like an unprivileged user, but like we're not there yet. There's still some more work to do.
So you're not
all
gonna
the checks.
you're not gonna go there until you're good and ready. It sounds like that's wonderful.
Exactly. Yeah.
Okay, it's good.
More complex security features are future. Yeah. The question is whether running an interpreter in kernel space is scary. Yes, the limits we've introduced, so say like explicit time limits and memory limits to provide. So like you can't eat up all the memory, you can't like have an infinite loop and just hang the kernel forever. Currently, we're kind of like in this space where, okay, you have to be root in a global zone, and so like you already are potentially able to mess up everything. But the Lua interpreter is fairly well sandboxed and pretty heavily limited to just this set of library calls.
Thanks so much.
How do the channel programs interact with normal ZFS IO? If I delete all the snapshots while that's running, I create a snapshot. What happens?
Can you repeat the end of that? I didn't quite
So
catch.
say I run a channel program to delete all my snapshots. While that's running, I create a snapshot. Does the snapshot creation get blocked until the channel program is done? Does it just get dynamically inserted into the list of things to delete, or is it erased?
Right, so the key here is that like both of those operations happen within a syncing context. So the channel program would run within like one sync, and even if it wasn't a channel program, even if it was just like a normal like delete a snapshot, the creation would not be able to run until after that is finished. Does that make sense? Like a sync is triggered. Yes, syncing context is single threaded.
Yeah, so either you create your new snapshot and then you run this channel program that, say, deletes everything, or you delete everything, then you create your new snapshot, but those can't happen concurrently. Sasha?
How many problems have you had to slide there to get Lewis where every number as it floats work in the kernel?
Yeah, so there's definitely a limit there. For example, if you try and get like the
Make sure to repeat the question. Sorry, guys.
okay.
Sure. The question was like, how do we deal with Lua having much looser interpretations of
Yeah.
numbers, mostly representing everything as a float?
Yeah.
For one, we made numbers in Lua in 64s instead of floats.
Right, but because they're in 64s, like, we definitely have some, like, it's a really big GUID, now it's negative when you return it.
All right. It looks like we are now out of time.
But you can come ask us more questions.
Yeah, we'll be around during lunch if you are curious about anything else. Cool. Thanks.